Graphing trigonometric functions. Trigonometric functions are in the form of y equals a sine or cosine b times theta minus c plus d. This is the form. This has transformations. We won't be doing a lot of those, but we will be doing some of those. We have amplitude, how high and how low, the absolute value of the amplitude because distance cannot be negative. The period for sine and cosine is 2 pi divided by b. Here's b. Whatever the number is in front of theta, that is the period, how often it's going to be repeating. We won't be doing too much with tangent because of this remote learning. We will mostly be doing sine and cosine and their inverses. We have a phase shift. It can be shifted left and right. It can be shifted up and down. Graphing trig functions, we're going to go in this order. Find the period, locate the amplitude, locate the zeros, sketch the graph, and then talk about the domain and range. We are graphing y equals sine theta. We start by finding the period. The period equals 2 pi divided by b, and b is the number in front of theta. Here we see the number in front of theta is a 1. We could say there was a 1 there. 2 pi divided by 1 is 2 pi. Our period is 2 pi, or because we are in degrees here, 360 degrees. I would mark off 4 equal parts. And at the fourth part, the period is 360 degrees. I would go to the halfway mark. Half of 360 is 180. And then the halfway between 0 and 180 is 90. And we can see we're going in increments of 90. 90, 180, 270, and 360. I could always work back on this side as well. Negative 180, negative 360. The amplitude, the highest and lowest points, the amplitude A is found in the front of the function like a coefficient. Here, I also have a 1 in front of sine. My amplitude is plus and minus 1. We will be using 0 degrees, 90 degrees, 180 degrees, 270, and 360. At 0 degrees, what is sine? Sine is 0 degrees. Cosine, sine, and we see that at 0 degrees, sine is 0. At 0 degrees, sine is 0. Next, 90 degrees. What is sine at 90 degrees? Cosine, sine. At 90 degrees, sine is 1. On the graph, at 90 degrees, sine is 1. At 180 degrees, what is sine at 180 degrees? Sine is 0. On my graph, at 180 degrees, sine is 0. What is sine at 270 degrees? Sine is negative 1. At 270 degrees, sine is negative 1. At 360 degrees to complete the cycle, what is sine? Sine is 0. We're on the axis, above the axis, on the axis, below the axis, on the axis. And I could use that same pattern on the other side. I am on the axis, and then I am below the axis. I am on the axis. I am above the axis, and I am on the axis. Below, on, above, on. There is sine theta. It's important to note where sine is starting. At 0 degrees, sine is 0, and so sine will always start at 0. That's important to know that about sine. Next, we have cosine. The period for cosine is the number in front of theta. We have a 1, so that would be 2 pi divided by 1. The period is 2 pi. I create my 4 equal intervals, and there is 2. We are going in degrees. That is 360 degrees. Half of 360 is 180. Half of 180 is 90. And we can see that we are going from 0 to 90 in increments of 90. That's going to be important when the functions get more difficult. You always take your period and put it at the end of your cycle, cut it in half, and then cut it in half again. Our amplitude A is found in front of cosine, and that would be 1. Our amplitude is going to plus and minus 1. And we start the same way. We make a chart and we start with 0, 90, 180, 270, and 360. What is cosine at 0 degrees? Cosine is 1. The cosine function starts up on the axis because at 0 degrees, cosine is 1. Cosine at 90 degrees. Cosine at 90 degrees is 0. Are you starting to see a pattern here? Cosine at 180 degrees. At 180 degrees, cosine is negative 1. 180 degrees, negative 1. At 270 degrees, cosine is 0. And at 360 degrees, cosine is back to 1. We are above. The next one would be on. The next one would be below. The next one would be on, and then above. So we are above, on, below, on, above, on, below, on, above, and going to below. And so again, it's important to know that at 0, cosine will always be on the axis. It's also interesting to note that cosine has tails that are heading in the same direction. What kind of function do we know that the tails go in the same direction, whereas sine had the tails going in opposite direction? This one is going up, this one is going down. That should tell you about sine and cosine and which one was even and which one is an odd function. When the tails go in the opposite direction, it's an odd function. And when the tails go in the same direction, that would be an even function. Okay, that's the basics of graphing sine and cosine.